All right, this is a continuation. This is video 2 on the pulsar. I have things pretty much where I left off. I'm going to demonstrate controlling the pulsar with a MP3 player. And I'm going to turn on the MP3, well, I'll turn it on once I plug it in. I'm going to unplug the function generator or my oscillator. In fact, I'm just going to turn that off. Now I'm going to plug in the MP3. This is a simple MP3 file, file player, stereo jack, and I made up a cable that reduces it to a mono plug, and it will deliver signal into the trigger on the pulsar. So if I turn the pulsar on, I have the night light still connected up. The scope is on. Nothing's happening because there's no signal coming out of here yet. So I'm going to turn the pulsar on, which I haven't done yet. On. You have to hold it down for a couple of seconds. It's initializing. And oops. Okay, it just initialized. You can see the light came on full blast. And I have 4 files in here. They're 10 seconds long a piece. I've set them up to cycle through one file, then to the next file, then to the next. I'll tell you what files are going, so it'll make it, it'll look like it makes sense with the way you see the night light working. So I'll start the file to play. Okay, right now it's running a 432 hertz. Whoops, okay, it was finishing up a 430. It's running a 432 hertz at 50% duty cycle. So the filament looks like it's nice and frozen. You can see the wave pattern. That was 10 seconds. Now it just switched to 4 hertz at a 5% duty cycle. And you can see it flashing at 4 hertz. And it just stepped up to 50% duty cycle. So each one of these files are only 10 seconds long. So if I don't talk fast enough, it's got to switch before I finish describing a file. It's at 432, 5%, just finished. It's 432, 50%, run for 10 seconds. And we're at 9, 10, okay. Now it's switching to 4 hertz at 5%. Very weak duty cycle at 4 hertz. It'll jump up to 4 hertz at 50%, much brighter, 4 hertz, and then it'll just continue cycling. So I can make up a chain of files or one file and just have it change within the file from frequency and duty cycle. And this has nothing to do with amplitude control that I still have using the volume adjust on my MP3 player. And that just means it biases the trigger transistor used to bias the MOSFET slightly different. When this comes back on, the brightest it will come on, and that'll be at 432, 50%. I'll turn down the volume a little bit and you'll see how it just plain dim. So I basically have also an additional intensity control outside the duty cycle. So the next file is going to bring up 432 at 50%. It's at 5% right now. And it's coming. We've got 9, 10. Here we go. Okay, I'm turning down the intensity. Well, I turned it all the way off. And it's out running and the file's all finished. Alright, well, I can change the intensity to about 5 different levels if I had let the file, made a longer file than 10 seconds. Alright, I'm going to stop this, and again, as you saw before, it's depleting the capacitor that stored up a significant charge because it's such a slight or low level current draw. And we're going to show something rather interesting. So I'm going to take off the plug. And don't want to touch these because there is some juice there. I'm going to take this off. And we're not going to, and I'm going to go back to using the function generator. We'll talk about the MP3 player a little bit more. I'm going to turn it on and it's firing up. And what I want to demonstrate first is a 110 volt LED light draws about 5 watts, and it delivers about 300 or 400 lumens. And I've bought several of these, and they had a couple of LEDs go out, and if they go out in the wrong way, it can actually disable the light, because they're all these LEDs are wired up in series. So I took one apart and I made up a LED plate. And this LED lamp has 108 LEDs in it. There's 96 around, and then there's 12 more up top. And I just made up a plate missing the 12. I'm going to plug this in, and we're going to look at the kilowatt meter and see how many watts it's drawing to give you full brightness. Turn it on. It's on. I know that's quite bright. And I'm going to change the, so it's drawing, yeah, you can see that. It's drawing 5.6 watts to run this, this light. And you can see about the brightness it's at. It's not that bright, but you know, you have 3 or 4 of these set up, you certainly can read by. It's very comfortable, and you're not drawing a lot of power. All right, with that, I want you to remember 5.5, 5.6 watts, and turn it off. Now we're going to show you what it takes to drive the same amount of LEDs, minus 12 LEDs. You're going to see an extraordinary difference using the pulsar. So here's one application. You want to save energy? I'm going to show you an application that saves a lot of energy. Lots of energy. We're going to set up our arrangement again. And being very careful, hopefully being careful enough. All right, we're running cool. I'm going to connect the output of the pulsar to this little panel that I have wired up with 96 LEDs in series. Well, they're not. That's not entirely true. It's a combination of series parallel. I'm going to turn on the unit, and I'm just getting a phone call. And I guess my wife picked it up. That's nice. Very good. And you see I'm flashing right now at the Showman's Resonance of 7.83. And I'm going to see what the duty cycle is. Switch over to duty cycle. And I'm at 4%. So this was on continuously. And it consumed 5.5 watts. This was on continuously consuming 5.5 watts. This is on flashing right now, and if I press the watts, it says about 0.3, 0.4 watts. It doesn't say stable. The interesting thing is that I can change the frequency to drive this, which I will do. Bring it up to I got it up to 57 watts. At 4% duty cycle, I'm drawing 0.4 watts. I hope you can see this. I think my screen is not blown up all the way. I think I saw the number 0.4 in there. It's 0.4 watts. And if I bring this up, if I bring the duty cycle up, It's running at 57 hertz, and if I bring the duty cycle up to from 4 up to just 25, I'm getting really close to the brightness that this guy was generating plugged into the outlet, and it's generating half the power. It's generating 2.5 watts. 2.5 watts. So bypassing the little bit of electronics that's built into the base here, I get a little bit. I get about 100% improvement on the on the LED light assembly, which is amazing. I think that's pretty good. So let's demonstrate a few other applications. I use this device. I've made multiples of these already, and I use this device to control my heat blanket, electric heat blanket that you sleep under at night. And instead of getting the 60 cycle source of electricity to activate the elements, I activate them at Schillmann's resonance at 7.83. 60 cycles is not good for you. Your body does not deal with 60 cycles particularly well, and Mother Earth, or nature's natural resonant frequency for this planet, Mother Earth, is 7.83. It changes. It's a little higher, a little lower, depending on where you're at and what time of the day and so forth, and what influences are going on in the cosmos. But it's roughly 7.83. And we evolved as a species based on that resonant frequency. It works for us. There are other frequencies that have extraordinary properties that will kill germs, promote cell growth, and that's where the MP3 player comes into play. You can set up a sequence of frequencies, and they can fire one after another, or you can actually build combination frequencies into a combination of frequency and duty width. And you get a complex, you can create almost a complex combination of frequencies that could possibly emulate two of the healthy frequencies. You can do some other things too. You can generate some bad frequencies. And I'll tell you a little story that is right on target. How many minutes I have? Okay, I think I'm going to have to shut this down. It's 13:06, and I'll finish this up with a third video.